Hello, everyone, and welcome to today's webinar, Starting Off Right, Improving Early Growing Conditions with the Seed Microbiome, sponsored by Heliae Agriculture. I'm Robin Sittberg of Meister Media Worldwide, publisher of CropLife magazine. Today we'll talk about the important relationship between the seed and the surrounding microbiome. Our speaker, Dr. Karl Wyant, will discuss the enormous impact this area has on early plant development, crop yield, and quality, and how that can be optimized to increase yield. This webinar has been approved for 1/2 CEU credit and crop management from CCA. To receive credit, you must watch the entire webinar. Your credits will be submitted 2 weeks from today, which is the live airtime. We'll have some time for questions and answers at the end of the webinar, and if at any time during the presentation you'd like to ask a question, type it in the question pane at the lower left panel of your screen and click Submit. You can do this at any time during the webinar, and we'll take care of questions at the end. Before we begin, I'd like to introduce today's speaker. Dr. Karl Wyant has more than 10 years of experience in ag science and data analysis. He possesses detailed knowledge of production agriculture as exemplified by his earned Arizona and California pest control advisor licenses, in addition to certified crop advisor and certified professional agronomist credentials. Dr. Wyant earned a PhD in biology from the Arizona State University with an emphasis in soil science, and he has a Master of Science in Ecology from Colorado State University. So now I'm pleased to turn the program over to Karl Wyant.
Thank you very much. I appreciate it. And thank you to the audience for logging in. For some of you, it's late morning, and for some of you, it's early afternoon. And we appreciate the time you're taking to learn about biological seed treatments and learning about how they might help you get that crop off to the right foot. So just before I jump into the content of the talk, I just wanted to introduce myself so you are assured that I'm a real-life person here on the other end of a webinar. And there's a photo of me taken a few years ago. It's actually my wedding photo. You gotta reuse those things. Got to get your money's worth. But as Robin said from CropLife, I have a range of experience in soil science. I got my start almost 15, 16 years ago, trucking around eastern Colorado, working on rangeland soil science. I then moved to Fort Collins, Colorado, and I did a master's degree where I studied Arctic permafrost soils. I got tired of being cold, so I said, you know what, let's go move to the desert, and that's what I did. I started a PhD at Arizona State University, and that's where I really got engaged with agriculture. I did some work with a vineyard in south central Arizona. I also did some work on some of the rangelands that are down here and looking at soil health and soil quality. Of course, when you finish your PhD, you need a job. So I picked up a job as an agronomist in ag retail, and I covered Arizona and California, starting off in the desert growing regions and then moving up to covering the whole, the 2-state territory as the lead agronomist. And recently I joined Heliae Ag, and I am now the Vice President of Ag Science, where I oversee the internal and external trials, and I also help out with the agronomy education like we're doing today. And thank you for your time, and thank you for your attention as I move through my slide deck. So at Heliae Agriculture, we're all about delivering solutions to growers to help them with their regenerative agriculture goals. And you'll see how we do this as I move through the talk. And you'll see how this relates to a seed treatment. And I feel that we have a very unique approach and a unique mode of action that's like anything that you've seen on the market today. First, I'd like to start, though, with just defining biological seed treatments, because this is an interesting sphere of the ag market, and there's some confusion about, well, what is exactly do you mean by that? And so I'll walk you through some history here. So a seed treatment, if you just look at the basic definition, is the exposure of seeds to certain agents, physical, chemical, or biological. So you can see there's a whole number of different things that you can do to a seed before you plant. And one thing about these seeds and this type of approach with treating the seed is that it's an old approach, it's an old technology. And you can see this table on the right side of the screen showing that, in approximately 2000 BC, there were farmers treating seeds. Of course, they were using some different approaches. They were using sap of onion cypress to help treat the seed, to help have an influence on those early growing conditions. You can move into the Middle Ages, and you can see some really interesting mixes here. Soaking in chlorine, salt, and manure. Sounds like a pretty interesting smell there, but that's what they had to work with. And this moved into the 1600s and even into the 1800s, where folks were soaking their seeds prior to planting in salt water, copper salts, the fungicide, even soaking seeds in arsenic. That didn't last very long because that arsenic seed treatment got banned for health reasons. And then moving into the last century, where they were using organomercurics to treat seed. And then finally we start to move into what we all know as modern seed treatments, and that's with starting in the 1960s, when some of these systemic fungicides were starting to be put on seeds, and moving into the what I call the modern era, which is as recent as the 1990s, where we finally had these modern fungicides and pesticides that we all know and love, that we treat our seeds with. And I'll mention some of those active ingredients as we walk through some of our trial examples. But you can see the approaches is not new, just the active ingredients. And I mention this because the biological seed treatment is the next evolution here. We have the fungicides, we have the pesticides and insecticides we're putting on seed. Well, what's next? And that's biological seed treatment. And that's what we're going to talk about today. So what's this market look like? Well, you have a number of different categories of these biological seed treatments, and finding a definition for what constitutes a biological seed treatment is interesting. Depending on where you go and where you live, you'll find a different definition, at least from a regular storage standpoint. But just from a basic operational sense, a biological seed treatment is a product that's derived generally from something living or something that's been recently living. So you can trace back that production pathway to something that was living. And this contrasts with a lot of our insecticide and fungicides, which are more, they're synthesized, they're created in labs, and they're not connected to living organisms. So these biologically derived products are applied and used in crop production to elicit some sort of response from that crop. And you can categorize them in a few different major categories. Seed protection, that's what most of us are familiar with, and that's an emerging category with the biofungicides and bioinsecticides. A lot of you folks on this webinar are already familiar with nitrogen-fixing inoculants and how you use those in soybean production and some of the pulse crop production. Are already familiar with the biological seed treatment. And this also goes in line with this inoculant, where you're adding other different types of bacteria and fungi and even mycorrhizae. And the goal here is to provide some seed enhancement. And I think the last category that's not often talked about is this labile carbon as a biological seed treatment. And this is the category I'm going to focus on today, providing a specific kind of carbon to fuel microbial growth below ground and help connect that microbial community to the seed enhancement and the seed performance early on. One thing about this whole market of the biological seed treatments is that it's really the next wave of what's going to become popular in our marketplace. And here's from some of the reports that I pulled. This global biological seed treatment was pinned at almost $1 billion in 2018. It's expected to have a global annual growth rate of 11.6% for the next 6 years. North America, we're large consumers of these biological seed treatments, and we represent about 40%, almost 41% of that total revenue for 2018. And our growth rate is pinned to roughly about what's expected globally. And I think the piece that's interesting here are the unique modes of action. We can explain very clearly how our fungicides and insecticides work. We have the IRAC charts, we have the FRAC charts. We can go pin it down to the different groups. But with these biological seed treatments, they have often unique modes of action that really require some digging and understanding, well, how exactly do they work and how do they impact my production system? I think from a marketplace standpoint, these seed treatments are really working hard, and these companies are focusing on fixing some of these early missteps that were made where maybe these biological companies had some snake oil image, and that's only corrected by renewed focus on mode of action and that R&D that it must have to happen in order to develop your mode of action story, showing a return on investment in the field, and then looking at these synergies. How do our biological products fit with current production systems? So with that, I'd like to introduce our PhycoTerra ST, and that ST stands for seed treatment. And our product from Heliae Ag is derived from microalgae, so it's a single-celled organism that lives in the soil. It's not the stuff that's in your pool or by the lakeshore. This is microalgae, and we've perfected how to grow it, and we've perfected how to create it at scale. And what we are able to provide with PhycoTerra ST is a superior food source that can go on your seed, and it can feed the microbiome. And I'll jump into those details here through the remainder of the talk. I mentioned we're a food source, so the question might be, well, what's in the food? And that's what we've done here is we've done a macronutrient analysis where we can show you the carbohydrate, lipid, and protein breakdown of our products. So we're 48% carbohydrates, 22% lipid, and 26% protein. So a very well-balanced diet to promote the proliferation of microbes below ground that can help influence that early seed growth. I'm showing a table of our fertilizer NPK percentages. We're not a fertilizer. We are a superior microbial food, and we've done a lot of R&D work on the back end to really draw that line in the sand. One piece, just when you're thinking about when to use a product like PhycoTerra ST, is really thinking about what drives seed success. So let's define seed success right off the bat. That's that seed emerging. That's the seed growing vigorously early on and getting that crop off to the right start. So really what PhycoTerra ST represents is this biological influence that you can exert on a crop early on to help promote your seed success and early crop response. You've already done the physical work. You've prepared the beds. You've prepared the field. You've already done the chemical work with your pre-emergence that you've put down, with your fungicide and insecticide that may be on the seed. You've applied your fertilizer. But what's often left behind is this biological component, and that's where PhycoTerra ST comes in. We fill this missing piece of the Venn diagram for the holistic approach to seed success, and we can help drive that response. And I'll show you some data that backs that up. So just some quick product details. This is our pricing and program, and this is suggested grower pricing in US dollars. We have a couple of different rates based on our previous research. On the cereals, we're expected to go out at 2 to 5 ounces per hundredweight of seed, and that suggested grower price there for that program is about $2 to $5 an acre average rate. You can look at the soybeans. We have some a recommendation for 2 ounces per 100 weight, and that's about $1.50 for soybeans. Once you adjust for the actual planting pounds per acre, that price drops down. Potatoes, 8.5 ounces per acre, and that translates to about $8.50 an acre on that seed treatment. And then corn, same as soybeans, 2 ounces per 100 weight. But once you adjust for that seed price, you see how low that investment is. Suggested grower price on corn is 42 cents an acre. And if you go look at cotton, with the planting rates for cotton, that's about 20 to 40 cents an acre, suggested grower pricing. We can get it to in a couple of different ways, 2.5 gallon jugs, or the 15-gallon kegs that'll fit into your more modern seed treatment system. So we can treat from some of the lower technology side for seed treatment all the way up to those modern systems that all the big seed treaters have. And for those 2.5 gallon jugs, it's $320 USD, and for the 15-gallon keg, that's $19.20 suggested grower price. So just some things to keep in the back of your head, and I'm showing you this because I calculate ROI down the road here. We're currently in the registration process. In all these orange states here, we have approval. It's ready to go for this fall. It's ready to be used. The ones that are in white, we're still waiting to hear back. And every week that goes by, we fill in more and more of this. So if your state where you live is not registered yet, just give it a week and it'll probably go orange. So most of the country is covered. We're just waiting to hear back here. So let's talk about this seed treatment option and what makes it unique. And remember, it's a biological seed treatment, that next evolution in the seed treatment industry, and it's a labile carbon source. So it's what I mean by labile is it's easy to eat. There's recalcitrant carbon, which is hard to eat. There's labile carbon, which is easy to eat. If you think about that in sort of people terms, recalcitrant carbon might represent you trying to eat a piece of wood, whereas labile carbon might represent you trying to eat bacon. They're both made of carbon. One tastes much better than the other. I'll let you decide which one. I hope it's not too much of a debate in your head. But that's the same thing for microbes. You have to give them carbon to fuel their growth, to fuel their metabolisms, and you have to give them the right kind of carbon, and that's where PhycoTerra ST comes into play. So let's just talk about the seed microbiome. The seed microbiome is that very small area that's represented by the interaction between the seed and the soil and the microbes. So as soon as you plant, you create that distinct zone in the soil. There's a science term for it. It's called the spermosphere. So the spermosphere is that first place in the soil where that seed now has interactions with that world at large. So that's where we want to influence, and our technology is formulated to fit on that seed, provide that carbon source, and optimize that spermosphere. So the relationship we're optimizing here is the fact that seeds pay for microbial work. The seeds will leak carbon into the spermosphere. The microbes can eat that carbon and provide work for the seed, and that work might be something like increased NPK mineralization to fuel early growth. So our idea here is to add a carbon source to the seed and help boost that bank account, that carbon bank account the seed's paying for microbial work with, and give them a huge checking account to pay for a whole bunch of work and get a whole lot more of that optimized seed and spermosphere in the soil. So here's a schematic showing what we're talking about here. You have this seed here in dark blue on the center of the screen. We add that high quality carbon source that's ready for those microbes to feed on, and we improve that bank account. We increase the checking account this seed has to pay for microbial work. And our technology in PhycoTerra ST is all ready to go. It's specifically formulated to promote this interaction. So here's a diagram from the literature that shows how this payment happens below ground. Here at the very bottom left of this chart, that's when you plant the seed. And the blue line that's stretching across the screen here, that's showing that seed growth and development. They're using water uptake in the seed because that water uptake drives that radical emergence, which is where your spermosphere ends, and now you have a growing plant and you transitioned into that root zone. So very short time. This is hours. So a very short time you need to influence. And these red lines are the payments of carbon going out. You see there's three major payments that are going out to fuel the microbial work in that spermosphere. And during that time, these payments are promoting microbial growth. What we do with our product, PhycoTerra ST, is we make those payments much bigger so the seed can pay for a lot more work. Here's an example of what we're doing, and this is from a plate test where we're culturing soil bacteria. This is from farm soil. And what we're doing is promoting abundance and diversity of those microbes by adding that labile carbon source. And here on the left side of the screen is our control soil. This is real farm soil. These are real farm soil microbes. We ask them to grow on these plates, and you've really got to squint here to see the improvement in performance. You got one colony coming in here on the very far left, but you've got to squint to see the rest of that microbial growth. We made one change to this experimental setup. We added PhycoTerra, which is that microalgae labile carbon food source, and you can see that response. You provide that payment, and those microbes can grow and provide work to that seed. Another piece that's worth talking about is recruitment. So your seed not only has to pay those microbes for work, it needs to recruit them to go to work for themselves. So that's what we're showing here. Here we covered some bean seeds with PhycoTerra, that premier food source for microbes. And then in the very center, we dropped in some very mobile bacteria. This is a Pseudomonas species, and we watched how it moved in the agar plate here. So what this is showing is that these bacteria, these microbes, can sense a good food source. It's called chemotaxis, and they'll move towards that superior food source. So here on the right side of the plate, that's a seed that's been treated in our labile carbon, our labile microalgae, the PhycoTerra. And then here on the left, that's an untreated control. You can see how they can sense that food quality, so that seed can recruit more bacteria, recruit more fungi, and pay for more work when you give it that labile carbon source. So next I'll start talking about some of our results here. And we started out with just looking at germination and just how that seeds respond to having the PhycoTerra on the seed coat, and how it was able to attract the microbiome and pay them for work. So here's an example of some of the work we started out in our greenhouse with. And on the left side of the screen, this is a wheat seed that has a fungicide and insecticide on it. And you can see that early root growth. Contrast that with the wheat seeds that have PhycoTerra ST. That's our seed treatment product at 5 ounces per 100 weight. These seeds also have the fungicide and insecticide on it as well. So if you're thinking compatibility, we can fit into your current program, your current fungicide and insecticide treatment program, along with this labile carbon source, which gives you that unique blend on your seed. And what I'm showing here is the change in that root morphology when that radical comes out. If you really squint and look at this screen closely on the webinar, you'll see some changes in root morphology early on. And this translates into some optimization in early growth in the plant. So here I'm showing on the left side, this is our untreated control, and by untreated I mean it only has the fungicide and insecticide, and you can see that earlier optimized growth there. Unoptimized growth, we add the PhycoTerra ST plus that fungicide and insecticide program, and you can see changes in that early growth and how we can optimize that performance of the crop right out of the chute. And so one thing that's interesting about this slide is that we did this under challenging conditions. This is soil that's at 40 degrees Fahrenheit, so cool soil, tough planting conditions. Some of those conditions we had last year, where it was tough to get some of these crops to come up. Well, that's what we were simulating with this slide here, and we're showing that change under challenging conditions, where optimizing your microbiome in the spermosphere could lead to those changes early on. And I'll show you this again because it comes up in the field trials that I'll show you here down the road. So that's what I'd like to talk about next. Is we moved from our greenhouse and we moved into field trials for winter wheat last year. And we did these wheat trials in North Carolina on some sandy loam soils, so challenging conditions, low organic matter, sandy soils. And I'll show you the results from 3 different locations across North Carolina on this next slide. And what I want to point out is that this is winter wheat, the cropland variety, and our control is a fungicide and insecticide. So it's not just a bare seed. It's what that grower was already doing for their wheat treatment program with fungicides and insecticides. And this is important because, you know, we're not trying to displace anything. Really what we're doing is adding a unique mode of action. So this fungicide and insecticide is a typical, three-way fungicide program, and then a neonicotinoid insecticide. So very common in the industry. We added our PhycoTerra to it. So you had your fungicide package, you had your insecticide package. Now you have your ability to provide payment for microbial work in the soil by adding PhycoTerra ST, and that's in these green bars. So across 3 sites, very, very similar sandy loam soil texture, we saw some impressive results. In Hassel, North Carolina, we had 4.5 bushel an acre increase over the fungicide and insecticide control, a nice ROI of 3.6. In Kenansville, we had a bushel acre increase of 2, or an ROI of 1.6. In Burgaw, North Carolina, we had a 7 bushel an acre increase, or an increase in yield, 7.6%, and that ROI was 5.5 to 1. So for every $1 spent on that PhycoTerra ST, that grower received $5.5 in return based on that local crop price. So I'm going to highlight this Burgaw, North Carolina trial here, and I'll show you some photos of what we've seen. It's in the back of your head. Keep in mind we treated the seed with 5 ounces of product per 100 weight of wheat seed that went out. That's our PhycoTerra rate. And I'll show you some pictures here. Here's the harvest. Here's that early growth. We planted in November, and this is from February of 2020. And on the left side of the screen here, you see the PhycoTerra ST plants. That's 6 plants that were collected randomly from that plot. And on the grower standard here, you have the 5 plants from the grower standard. So if you just draw a line down the middle, you can see that optimization in the seed microbiome with PhycoTerra ST is leading to some observable changes in the improvements in plant growth. So if you look at the root morphology, very different when you compare the PhycoTerra ST side on the left to the grower standard on the right. If you can see well enough and you can count tillers, kudos to you for being able to do that. I can't do that super well from a slide here, but we did count the tillers, and we have 40% more tillers on this PhycoTerra ST side relative to that grower standard. So we optimized that microbiome as soon as that seed was in the ground. We optimized the spermosphere, gave that seed the increased ability to pay for work and put those microbes to work that are already in the soil, gave them that labile carbon with the PhycoTerra ST. And here's that improvement in plant growth. If you fast forward all the way to harvest, here's what those final plants look like. And this is out of Burgaw, North Carolina, where we had that 7 bushel an acre increase. On the left here is our PhycoTerra ST plot, and on the right there is the grower standard. And what you can see is changes in that root morphology that carried its way through the season. Plant height's not super different. And what I wanted to point out here is the grain heads. So I'm going to show that on the next slide, but that's where we saw the most difference in these plants. Was we optimized that soil microbiome, and we saw some differences in the grain heads that we used to explain our final yield results at the end of the trial. And so we clipped these grain heads and we arranged them in a similar way, and I'll show you those next. So here's those grain heads, same plants, selected five places from different places in the field. So it was randomly selected from each plot. Grower standard, we got 5 grain heads. On the PhycoTerra ST side, remember we got that 40% improvement in tillering, and there's expressed in those number of grain heads collected off of the 5 plants. So really, really cool way to think about increasing yield in small grains. One thing I'm not showing here is the test weights we got back, and those were increased by a couple percentage points, so a little bit heavier on the grain. It's hard to see on this slide, we have a whole bunch of research that we're doing for 2020, looking at all the commodity crops and PhycoTerra ST, and I'll showcase some of that here later. But this optimized spermosphere and optimized plant performance early on is what we typically see. So it's a really promising approach here. On this next slide, I'm showing some of our research that we've done across corn, soybeans, and wheat. And just keep in mind that some of this work is early work, early editions of our PhycoTerra ST product. We're on the second generation now of formulation, but our corn and soybean work here was done using our first generation. So we've made some changes to make it even better, to make it work even better below ground, and to interact with your fungicide and insecticide programs and even inoculants that you're putting out. So one thing just to point out is on corn, we put out a really low rate, 1 ounce per 100 weight, and on that super low rate, on the bottom end of our recommendation range on our label, we had a win percentage of 67%, and if you look at the average bushel an acre increase on those trials that we won, 4.4%. So really promising at low rates, and we've continued this line of research in the second generation formulation and looking at even higher rates, that still leave room on that seed for real estate for your fungicide and insecticide program, and we expect those results any day now. Same for soybeans, number of locations across the Midwest, 13 different trial locations, 1 ounce per 100 weight, about a 70% win rate, and that average bushel an acre percent increase, about 4.1% on those trials that we won. And then wheat, that's where we have the most research across this rate range. We have some work done at 1 ounce per 100 weight, and the work I just showed you was the 5 ounces per 100 weight, and then we have an 80% win rate there and about a 5 bushel an acre increase percentage-wise on the wheat. So we've got a lot of trials going on now from Western Canada all the way through the United States, looking at just about every commodity crop you can imagine. Canola, we've got it on corn, soybeans, wheat, and we've got it on cotton. And we see a lot of potential here for a wide range of commodity crops that could use some labile carbon in their seed treatment program. They're already running the insecticides and fungicides. They're running the inoculant if you're using something like planting soybeans. What's missing is that labile carbon source, and that's where our product provides that unique mode of action. And I think a unique product in your seed treatment library. So we have some other applications that we've tried besides the commodity crops, and one piece where we've tried PhycoTerra ST is on cover crops. Cover crops are becoming more popular in the agriculture industry, and cover crops are becoming more and more recognized for their ability to impact soil health, soil quality, and help with manage some of the externalities like runoff, compaction, those sorts of things. So we've looked at applying PhycoTerra ST on cover crops, and I'll show you some of those results here from 2 trials we've done in our greenhouse facility at our campus in the Phoenix area. So that's what this slide is showing. There's 2 trials here. Trial 1 is this cereal rye. This is winter rye, the most popular cover crop in Iowa. And we treated this rye seed with 4 ounces per 100 weight, and then we planted and grew it up in our greenhouse. And what I'm showing here is that fresh weight biomass above ground for the cereal rye, and you can see with treating it with that PhycoTerra ST, we had 14% higher weight on that fresh biomass relative to the untreated control. And these are true untreated control. There's no fungicide or insecticide here. It's just bare cover crop seed going out, and we're just making that one change with PhycoTerra ST. So 14% improvement on the fresh weight here for cereal rye. We did a 13-way mix, and then we picked out the legumes because that's one of the reasons why those mixes are so popular, is because they contain legumes that can help fix nitrogen. And we picked out the clovers and we weighed them. And this 13-way mix was also treated with the 4 ounces per 100 weight. And what we found was we had a 36% improvement in that fresh weight biomass. So clearly we're causing something to happen with these cover crops, and we're excited about the potential here as we move down in our research program and as growers start to combine the PhycoTerra ST with their cover crop program. And then we also took some photos. Here's the root systems. If we're seeing improvements above ground, that should translate to below ground improvements and optimization of those root systems. And that's what we're seeing, a little bit higher root density here on these photos relative to that untreated control. So if you are using cover crops, I'd say that PhycoTerra ST can help you optimize your cover crop function. So what I'm showing here is sort of a ranking of what cover crops can do for you. On the left here is winter rye. If you're looking for these sort of soil functions, let's just say a nitrogen scavenger, you want to keep your nitrogen on your field by putting it into that cover crop biomass over the winter. Those results I showed you should help drive more growth, drive more nitrogen scavenging. From a grazing standpoint, 14% more fresh weight of ryegrass. I mean, that's 14% to feed whatever livestock you might graze there on the field, if that's what you choose to do. For the crimson clover, that's what we picked out of that 13-way mix. We increased that biomass by 36%. Just think of those optimized cover crop functions, helping to improve the loosening, of that soil, helping to prevent erosion. And then finally, that's 36% more above ground clover mass for your livestock to graze on. If you are looking into getting into cover crops, there's a really good guide, $5 from Purdue and a whole bunch of the Midwestern universities. It's small. It's 162 pages, but you can fit it in your shirt pocket. I highly recommend you take a look and Google this. It's the Midwest Cover Crops Field Guide. It's a great resource. That's where this slide came from to help you kind of pick what you might put on your field based on your desired goals. So I highly recommend you take a look at that and make that a resource available to yourself. And like I said, it looks like it's a big book, but you can fit it into your shirt pocket and take it with you. Another place we've used our PhycoTerra ST product is on potatoes. And here we're treating the potato seed pieces at 8.5 ounces per acre. And this is the final treatment picture here. And what this is showing is the PhycoTerra ST plus that combination fungicide, insecticide, seed treatment product as well. So we put them together, and now you have a really unique seed treatment program that can give you lots of benefits. So we're waiting for those field trial results to come back, and we're excited to see where that goes. One piece I wanted to mention was this program approach. Heliae Ag has a product family, and so we have optimized our microalgae formulations to fit the different soil interaction spaces. So I've been talking about this spermosphere, and that's that seed, soil, and microbe interaction space. That's for the PhycoTerra ST. However, once those roots appear, now you're dealing with a totally different environment, and that's called the rhizosphere, and we have a product available for that rhizosphere. So what I'm going to show you is the 1-2 punch, optimizing your spermosphere with the seed treatment and then coming in behind it with that rhizosphere treatment, and that's our regular PhycoTerra product. So here's a schematic that shows how this might play out in a crop's annual life cycle. We're treating that spermosphere early on with PhycoTerra ST, and then we're also treating that rhizosphere, that root zone, with the PhycoTerra or our organic formulation, PhycoTerra Organic. So we're hitting both microbial zones, and we're seeing some pretty impressive results, and I'll walk you through that shortly. Don't forget, you can treat your cover crop seed with PhycoTerra ST, and that's if you're interseeding or if you're planting in fall, as some of you might be now, there is an opportunity for that ST at the end of the season. But I'm going to focus mainly on this beginning of the season where we're hitting the spermosphere and then the rhizosphere. So that's what this first test shows, and this is corn dry weight. We tried this idea in our greenhouse, and what we found was that by This orange bar is the dry weight of corn at V9, just alone, untreated corn seed. And then when we added PhycoTerra, we had a 7% improvement in that dry weight. We added the PhycoTerra ST, we got the 77% improvement in that dry weight. But we added both products, so we hit the spermosphere and the rhizosphere at these rates that are shown here in the circle, 103% improvement in that dry weight. So if you're thinking of corn and the size of that photosynthetic engine, which is so highly related to the vegetative biomass, here's a good way to think about how do I optimize that. And it really starts at that beginning, really optimizing the microbes below ground to help drive that improvement in the crop growing conditions. So there's corn. We also have soybeans. I'll walk you through this photo. Here we have our soybeans standard practice, and this is on no-till ground in North Dakota. So standard practice, and here we have a bunch that are treated 5 ounces per 100 weight, and you can see the change in the growth here on the left panel. If you scan your eyes over to the right picture, you can see the combination program where we treated with the seed treatment product to hit the spermosphere, and then we came back with the rhizosphere product to treat the root zone, and we see some nice changes in that growth relative to the grower standard, and even that seed treatment alone. So really promising stuff. If you look at some of our early indications on soybean yield, and these photos were taken in August, and it's set up the same as what I just showed, where we have our untreated here on the left panel. You can compare it to the seed treatment alone. But if you take a look at this right panel and count the pods on that combination program, the PhycoTerra ST plus the PhycoTerra, some really nice early results for pod counts. And we're excited, and I've knocked on just about every piece of wood I can to make sure that this yield trial goes through, and from our replicated CRO work and third-party analytics, just to make sure that we can capture this value and showcase it later. We've also been looking at wheat, same system, no-till in North Dakota. You can see the standard practice and the seed treatment there on the left panel. But when you look at that right panel, you can see the combination program, the 5 ounces per 100 weight and the 2 quarts per acre, hitting that spermosphere, hitting that rhizosphere, and how it impacts that early growth on the wheat plants compared to the grower standard and compared to just the seed treatment alone. And here's some photos of grain heads, and we're waiting for this yield data to come in, and we're excited. If you just look closely at the right panel and just compare the grain head morphology to the grower standard right next to it, you can see some exciting implications there for the yield, and we'll translate this all the way to the quality in terms of protein. So I'm going to wrap it up here and end the talk. I've got a couple more slides, but what I'd like to talk about is just this where the biological seed treatment is going. Now, I've been talking about this labile carbon as a biological seed treatment with PhycoTerra ST, and just remember that's one of many biological seed treatments. And I think this category is worth exploring. If you've been relying on your fungicides and insecticides for a long time in your seed treatment program, maybe you've put in an inoculant in your seed treatment program, I think time is right to try the next step and to explore something in this biological seed treatment category. There's lots of potential here, but I think one of the main issues is that there's lots of modes of action. I've been describing for the last 30 slides one particular mode of action, the labile carbon MOA, where you can use that microalgae in PhycoTerra ST to feed that native soil microbiome, pay for more work below ground, and drive that optimized crop response early on. But as I mentioned at the top of the hour, there's several other modes of action. And I think that's where most folks get a little tripped up here, is they see these products and they don't quite understand where it fits in their operation. And I think this is where your trusted crop advisor could help you out in some of the ag media, like those articles that appear in CropLife, where you can get that description of the mode of action and see where it fits in your program and help guide some expectations there. So talk to folks in your area, talk to your favorite crop advisor. You probably have them on speed dial already, let them know what you're thinking, and they can get you squared away on understanding exactly where this product fits in the broader scheme of the biological seed treatments. As I mentioned before, PhycoTerra ST, we can provide that carbon source that can feed your microbiome that's in your spermosphere. That's what our technology is built for. That's what our formulation is made for. And so we can very clearly define our mode of action. If you'd like more information about PhycoTerra ST and microalgae, I'm popping up an email address on the screen here. You can email this address, and we'll get back to you with more information and with next steps. I know this concept might be new to some of you folks, and we'd be happy to clarify the mode of action, help you understand what it's compatible with what you're currently doing with your insecticide and fungicide programs, and where it could fit, rates, all that different type of thing, and we'd be more than happy to help you out. So info@heliae.com is the address, and please let us know if we can help you out and answer any questions or receive any comments from you. I'll leave this up for just a few more seconds for folks to jot it down. The one piece I'd like to bring up is just the resources. Biological seed treatments, while they're old. I mentioned that 2,000 years ago, people were soaking their seeds into cypress sap, onion cypress sap. So this biological seed treatment's not super new in terms of agriculture history, but in terms of modern biological seed treatments, it's new to a lot of folks. So on this resource page, I'm giving you some links. Or if you want to take a look at, well, what does the biological seed treatment market look like, an overview, there's that first link. That CropLife article on seed treatments, just the category in general, how they've worked to improve their R&D, mode of action definition, ROI, and value proposition. There's a link for that. If you really want to go and dive into the weeds here, there's an academic review on the category. If you want something a little more easy to chew on, we have a PhycoTerra blog, and you can read articles from me that talks about soil health, soil quality, and how microalgae is connected into it. And if you're sitting here scratching your head, well, what is microalgae? I even provided a link to the introduction to microalgae. Remember, microalgae is a unique organism. It's a single cell critter that lives in your soil, and it's not the stuff that's in your neighbor's pool or on the side of the lake. That's macroalgae. We're microalgae, and Heliae has perfected how to grow that. And if you need more information, there's that link on the bottom. That's the last slide of my talk. I really appreciate your attention, and I appreciate your interest in the biological seed treatments. I hope none of you go home and decide to recreate some medieval seed treatment conditions with chlorine, salts, and manure. Your wife might get mad, or your neighbors. Let's not do that. Let's stick to the modern biological seed treatments and promote success that way. If you'd like more information, if you want to peruse through our website, here it is, www.phycoterra.com. If you'd like to email us with any requests for content, or you have questions that we might be able to help you out with, or you'd like to get product, you can email us at this email address here, and we'll get you connected in. And with that, I'd like to hand it back over to Robin and the CropLife folks for a Q&A session. Thank you.
All right, thank you, Karl. We have been getting a lot of questions in already, so we'll get to those in a second, but I just want to remind you, if you haven't asked a question already and you'd like to, just type it in your questions pane at the lower left panel of your screen and click send. So we've got a number of questions coming in. A lot of them have to do with how to use and apply PhycoTerra, so I'll get started on some of those. First one is, will PhycoTerra ST fit into my seed treatment equipment?
Yes, great question. The PhycoTerra ST is packaged in a manner so that we have the 2.5-gallon jugs available, and that can fit into some of these, I call them low-tech seed treatment systems, and that's, folks mixing seed, in their front-end loader, or in cement mixers or even mason jars, whatever whatever low technology option you have for some of these seed treatments, that's no problem. On the higher end systems, we have the 15-gallon kegs that are available, and that can fit into the modern high-tech large-scale seed treatment systems, no problem. And we've tested all this in the field from the low end of the technology scale all the way to the high end, and there's no problem with fitting into your seed treatment system. One piece I wanted to mention is that we are a biological product, and agitation is key right before you use it. So you can shake a 2.5-gallon jug, no problem. Some of you might be wondering, well, how the heck do I agitate a 15-gallon keg? And that's a great question. One, go find a guy from the football team to help you out. If you don't have that available, our keg is built in with a built-in agitator, so you can stick a drill bit into the key on the top of the keg and agitate it the easy way without too much sweat or hassle. Great question.
Okay, great. Here's another one on application. Is PhycoTerra applied on the seed by the farmer in the planter box or by an ag retailer through bulk seed treaters?
So far, we've done the bulk seed treaters, and we've done that in a number of ways, like I just described. Some folks have used really low technology seed treaters, and some of them have access to the high-end ag retail large-scale treatment system. So usually it's done not in the planter box. We don't have that seed treatment technology yet for the planter box, just that a priori seed treatment option. Thank you.
Okay, all right. We have a listener who is wondering if they maybe missed a detail on timing and mixing. The question is, how is PhycoTerra applied in the crop at the 1 quart to acre to 2 quart acre rate? Do they do it foliar or in furrow? And also, what is the timing for that kind of application for corn and soybeans?
Sure, great question. So that PhycoTerra is referring to that rhizosphere product, and it's in some of those synergy slides that I showed earlier. That PhycoTerra product is generally applied in furrow, 1 to 2 quarts an acre. You can also put it out if you have a pre-emergence application or a burn down. You can also put it out through the spray rig onto the planting zone to get it out that way. So there's a number of different ways to get out that rhizosphere product. And typically what we recommend is get it out as early as you can so you can influence and optimize that soil microbiome as early in the crop's life cycle as you can. Thank you.
Okay, this is a good question as well. Could you please clarify the mode of action of PhycoTerra and its compatibility with other synthetic and biological seed treatment products?
Sure, no problem. So the mode of action is, in a nutshell, it's labile carbon. We are providing a premier and superior food source to feed the native soil microbiome that's already in your soil. We're giving them a really high quality food source to help promote their proliferation. And that seed treatment option to get this food source right on the seed itself, that serves to extend and drive that checking account that the seed has to pay for early microbial work. Remember, a seed is already exudating carbon from the seed itself to pay for work. We just make that checking account much, much bigger by providing a labile carbon source. In terms of the compatibility, we've done a lot of compatibility testing with our seed treatment product, even our PhycoTerra product that's for the rhizosphere. And what we find is we don't have many issues mixing with different ag chemistries, including the synthetic ag chem products or even fertilizers. One piece I want to point out though is that the pH of PhycoTerra ST is a little low. It's just to keep it preserved and keep anything from growing in it before you want to use it. So the pH of the product is around 3.5. If you want to combine PhycoTerra ST with some sort of living inoculant, say for soybeans or for alfalfa, or even some of the living trichoderma or bacillus species that are popular, one thing you'll need to do is treat the pH in between adding the PhycoTerra. You'll need to bring that pH up to more neutral, and you can use that. You can do it really quickly with something like potassium carbonate that's commonly found, and you can do that in the keg. You can do that in the jug. You can do that in the tank, and then add your inoculant, and then everything will be happy. You get your food source from the PhycoTerra and the PhycoTerra ST, and you'll get your living inoculant that'll stay viable and that can go to work for you in the soil once you apply it. Thank you.
Okay. Our next question is must be from someone in Canada because they want to know if you're looking to register in Canada.
We are looking to register for this in Canada. We see immense potential in the Canadian markets with canola, with pulse crops, with wheat, and we're working diligently right now with the Canadian regulatory authorities to get it going, and we're expecting to make some progress on this here Q4 for 2020, and hopefully be able to make some announcements in 2021. So that's a project that's ongoing, and we can keep in contact with you and keep you posted on when we get approved from the Canadian regulatory body.
Okay, excellent. Now we have a question on potatoes. Can we increase the growing conditions of a potato by augmenting with microbes of potato tuber? Is this feasible to treat a huge amount of seed potato tubers?
Yeah, so I mentioned that in my talk. We have a trial out right now where we treated seed pieces at 8.5 ounces per acre. And we also, in that same seed treatment blend, was a common fungicide and insecticide package, a 3-way fungicide mix with a sedexane in it. And we're expecting those yield results and quality results to come back within the next month, and it's definitely a viable approach for potatoes, and we've explored that for 2020's trial campaign. Thank you.
All right, this one is about timing. How many weeks or months in front of planting can PhycoTerra ST be applied to the seed, or does it need to be applied the day of planting?
So we're working on that question right now. We have some seed where we treated it in 2019, and we are going to go into some experiments here in our greenhouse where we look at efficacy 1 year after planting to test for that. But as long as that seed stays dry and it stays and it's not stored wet or anything, we expect what we expect is for folks to be able to treat with our product and have it sit on the seed and be able to see some efficacy at planting. And I'd say right now, 1 to 2 months before planting seems like a reasonable window, but we do have some trials that are upcoming where we'll be able to test that a year out. So great question.
Okay. All right, we've got time for one more question here before we have to wrap up, but it's, have you measured directly the changes in the microbiome? Have you measured directly the changes in the microbiome, either in the field or on the seed, with PhycoTerra products with methods like qPCR or RT-qPCR?
Yes, we have an extensive set of slides from our PhD in microbiology, Dr. Chen. He heads up that arm of our R&D campaign, and we've done a lot of work with soil from those plate tests like I showed you earlier, which provide a very visual response. But we've also taken that down the road of the DNA extraction using modern sequencing techniques and PFLA analysis, and we see a similar result where we're applying our product increases that abundance of the microbes and also helps with that diversity. So we see that whether you're looking at a very visual plate test or in the next gen sequencing with the DNA. We're still working on the spermosphere story. As you might imagine, extracting DNA out of the spermosphere is very difficult, and we're working on those methods right now, and we're hoping to have some slides here down the road that shows that direct change in that spermosphere when you add that that checking account, that labile carbon source, and allow that seed to pay for more microbial work. So that's an experiment. It's actually in progress right now, and that's a great question, and thank you for that.
All right, well, we're running out of time, so we need to wrap up. I know a lot of you have questions that we weren't able to get to, and rest assured, we'll save those, and the folks at Heliae can get back to you shortly with answers through email. So I appreciate your questions, and of course, we appreciate your time today on, just spending time with us on the webinar and learning about this kind of new old mode of action. And as a reminder, an on-demand version of the webinar will be archived in the next few hours, and it'll be available at the same link you used to, get online today. In addition, we will be sending out a PDF of the presentation afterwards. Some of you have asked about that. And you can also find the link at croplife.com/webinars. So again, thank you to Dr. Karl Wyant and to the folks at Heliae, and have a good afternoon.
Thank you.